we have had in our all our lectures now, we have had the data on cards, which is not very convenient for a program to read. So let's see how we can present the cards in a different way using tables. So for us, each card has been a unit of information. For instance, when we had grade cards, each card was a unit of information about one student, and it had various attributes. For instance, there is the card ID, which identifies uniquely which grade card it is, and then we have these different fields like name, gender, date of birth, the different subjects, and the total. So what we need to do when we look at such a card as a human being is to identify all these important attributes and the values of them. So for example, we look at it and we can see that the physics marks is 72. Now this is not a very convenient format in which to present the information to an algorithm or a procedure. So a better way is to organize it as a table, and in the table what we will do is we will convert each of these attributes into a column. So each card now becomes a row in this table. For instance, this particular card and every card in the grade card set has precisely 9 attributes. It has the card ID, the name of the student, gender, the date of birth, the city, the maths marks, physics marks, chemistry marks, and the total marks. So if we now make a table with 9 columns, then we can write out these values for each card as a row. So for instance, Kavya's card has ID 10, name Kavya, and so on. So if we pick up a different card, for instance the card for Siddharth, then this becomes a new row in this table. So in this way, row by row, we can enter the details for each card in this table, and finally we have a single table which represents the entire deck of cards. So this way we have a single compact data structure which allows us to look at all the information across all the cards, and at the same time, by looking at the row and the column, we can precisely get, for instance, in card 17 we can look at the city and say that it is Chennai. So it's very easy to extract information from this table by looking at the row ID and the column ID. And most importantly, we now have a single structure in which all the data is, so we can pass it around just like we have been passing around other things to our procedures. We can pass this around from one procedure to another. So the other kind of data set that we had was words in a paragraph. So once again, in this we have some attributes. We have the card ID, we have the word itself, then we have the part of speech, and then we have the letter count. So we can now represent this as a 4-column table which has these 4 values, and if we take a different word, for instance considered, then the ID is different, the word is different. Now the type is a verb and its length is 10. So far so good. Now let's look at the third artifact that we had, which was the shopping bill data. So what are the attributes in the shopping bill? So we have the shop name, we have the bill ID, and we have the customer name. So these are single values which occur once on the card. We also have a total which occurs once on the card. But what we have on the other hand is these items which correspond to the individual bill items which are bought by the customer, and there are multiple rows of this in each card. And the problem is that the number of rows is not the same. So for instance, if you look at Akshaya's bill, it has 5 items, and if you look at Srivatsan's bill, it has 7 items. So how do we keep track of this in a table? Because if these are our attributes, if item, quantity, price, cost are also our attributes, then we have to store them as columns, but the number of columns will depend on the number of different copies of this which are there as rows in the shopping bill itself. So this is a variable quantity. So we could have a variable number of columns, right? So for each, so we could have, one block of columns corresponding to the first row of this, then another block corresponding to the second row, and so on. But then what we'll have is that we'll have Akshaya's, for example, Akshaya's row will end here, Srivatsan's row has 2 more items, so it will end here, somebody else might have a much smaller thing, and so on. So we'll have a very ugly structure which is not a table at all. Each row will have a different length. So this is not a table at all, and this is not something that we want. So how do we squeeze this information into a table format which has a rigid structure of having a fixed number of columns for every item in our data set? So one solution is to have not one row per card but multiple rows per card. Of course, then we have to make sure that all the rows for a given card are tagged in some way so that we know that this whole thing corresponds to a single card. So let's see how to do this. So here is Akshaya's card again, and here is now how we will represent it in a table with a fixed number of columns. So we have these 3 columns, which are of course not a problem at all because we have only one ID, one shop, one customer on this card. This column is also not a problem because we have only one total at the bottom of the card. But the other columns correspond to the different rows in the card. So we have these 5 rows in our table and we have 5 rows in our card. Correspondingly, we have 5 rows in the table. And how do we know that these are all from the same bill? Well, in particular, they all have the same bill ID, so they must be from the same bill. So that is the real information that we need. But because we are forced to write down this information on every row, we also have 5 copies of the name of the shop, 5 copies of the name of the customer, and 5 copies of the total, right? So we have this unnecessary duplication of shop, customer, and table, total across the table. We have to duplicate ID because if we don't duplicate the ID, how would we know that these 5 rows belong to the same bill? So we need some way of connecting them by having some value which is common to all of them to say that they're the same bill. But we need not, we don't want to unnecessarily duplicate, or we should not ideally unnecessarily duplicate because we are wasting a lot of space in keeping track of this data. And now if we move to a larger bill, for example Srivatsan's bill, then the duplication would become 7 rows instead of 5 rows. So this is one unavoidable consequence of keeping multiple rows corresponding to variable length entries in a card. So when we have data like the shopping bill data, we have a small problem translating it to tables because of having to make these kind of adjustments. There is a slight improvement that we can do, which is to split this actually into 2 separate tables. One table corresponding to the values which are fixed for a card and one table corresponding to the variable rows that we need to represent multiple columns in the card. So for instance, in this case, we will take these 3 constant values, shop, customer, total, customer and total value, and put it into a separate table tagged by this bill ID. And separately we will have another set of 5 rows tagged by the bill ID which has these 5 columns which change from row to row. So now together we can merge these 2 to form the total bill if we need it, right? So we have one table for the fixed columns and the second table for the variable entries. Now the advantage is that the only duplication that we have is the absolute minimum duplication, which is that we need to record the bill ID for each row in the second table so that we can link this bill ID to that bill ID and make sure that together all of these constitute the same bill. So for instance, if we look at Srivatsan's bill, then this would have now 7 rows here because there are 7 items in the bill, but it has only one copy of the customer information recorded with the bill, that is the name of the shop, who the customer was and what the total amount was. So this is another way of representing this kind of variable data in a table. So to summarize, it is convenient to take the data that we have been working with on cards and put it into a table because tables are much easier to represent and they also keep all the data in one single data structure. So in the table, each column represents an attribute and each row represents a card. But we saw that with the shopping bill kind of data, if you have some variation in the attributes across cards, then you will have a variable number of columns. So one solution for this is to have multiple rows for each of the variable quantities in the card, but then you have to duplicate all the fixed quantities. The other solution, which is more complicated, is to somehow split it into 2 separate tables. One of them has the fixed quantities, one of them has the variable quantities, and then you need to use some unique attribute like the bill ID, which is not shared across different data items, to connect these 2 tables and make sure that all the data for a single bill can be recovered from these tables.